Assalamu alaikum, Shawir. Assalamu alaikum, Shawir. How are you?
So I'm good.
Hope you are doing well and everything is fine.
Yeah,
Okay. So, are you ready for today's lecture number 18?
yeah.
Okay. So, have you revised previous lectures? Any question regarding previous lectures?
No, not really.
Okay. So, let's start today's lecture number 18. Let me share my screen with you.
Yeah.
So, my screen is sharing with you, right?
Yeah.
Okay, so our today's lecture is lecture 18, and in this lecture, we will discuss about gases law and kinetic theory. There are three states of matter are there. The first is the solid, the second one is the liquid, and the last one is the gas. In today's topic, basically, we will focus on the third, which is third state of matter, which is the gas. We will discuss. There are some two important laws of gases are there, and then we will move on towards the kinetic theory of gases. So our learning objectives are we will understand the behavior of gases and their relationship with pressure, volume, and temperature. And then we will discuss about a detailed note on Boyle's law, what is Boyle's law and what is Charles' law. And we will also see their mathematical expressions. We will also plot their graphs as well. And last, we will discuss about the kinetic theory of gases behavior. Okay.
Mhm.
So for the introduction of gases, can you tell me a bit about gases? We already studied about states of matter in previous lectures. The introduction is same which we discussed. Can you tell me a bit about what is gases?
Uh, like when the particles are spread about and they're not fixed.
Yes, you are perfectly right that particles are not fixed and they are moving randomly. So yes, gases are made up of tiny particles. Everything in the universe are made up of small particles, which is atoms or molecules. And those atoms and molecules are in random motion. This is known as gases. But in the case of gases, they are not in perfect shape. Their motion is perfectly elastic and random motion. These particles move in all directions, not a specific direction. They will move in randomly in all directions, and they frequently collide with each other and also with the walls of the containers. Here you can see the illustration. I have a container, and in this container, these red balls you can see are basically the small particles. You can also say atoms, and they are in random motion. They collide with each other, also, they collide with the wall of the container. And when you increase the pressure, what will happen? The volume decreases or increases.
Um,
In second
and
part, here you can see
decreases.
the volume is
De
great. And but in this figure, when you increase the pressure, when you push down the piston down, those molecules of the gas now compresses. And in that
Mhm.
scenario, the can you tell me the volume is more or less, decreases or increases?
Decreases.
Yes, decreases. Here you can see the greater volume, and when you apply pressure, so volume decreased. So this would happen when you apply pressure on gases. When you apply pressure on gases, their volume reduces. Keep remember this fact. Okay.
Mhm.
Okay, gas pressures also caused by the force of collision of particles by the container. You know that everything in the universe possessed force, okay, caused force.
Mhm.
And gas particles also possessed force. And how they possessed force? When they collide with each other and when they collide with the wall of the container, they exert pressures as well. And in this scenario, you can see the pressure is less because those molecules are spread apart And but in this scenario, can you tell me the force is more or less?
Um, more.
Definitely, yes, more pressure. Why more pressure? Because here you can see the particles are now closer to each other. And if they are
Uh,
close to each other, it means they will now frequently collide with each other as well as with the wall of the container and exerts force. And the number and the speed of the collision determine the gas pressure. The greater the number of collision between these particles, the greater is the, you can see, the gas pressure is. Okay, because you know that gas is measured in terms of pressure.
yeah.
So you can see here the jar on the right has high pressure. Here you can see high pressure. Then on the right one, here is less pressure. When you push down the piston, the pressure increases, and when the pressure increases, as you tell me before, that the volume decreases. And when the volume decreases, the force between the particles increases and they will exert force on each other as well as with the wall of the container. So this is basically the introduction about gases. Any question?
Mm, no.
Okay. Now move on towards the kinetic theory of gases. Kinetic motion. Can you tell me what is kinetic motion? We will discuss in our starting lectures. We discussed two types
Uh,
of motions. One is the kinetic and the other one is the potential motion, if I am right.
yeah.
Yes. So can you tell me what is kinetic motion? Kinetic motion.
Um,
Basically, kinetic motion is the motion due to the motion of particles.
mm,
Okay. So if
yeah.
a molecules are in motion, so you can say those molecules have kinetic energy. And if molecules are at rest position, it means those molecules do not have kinetic energy. So kinetic energy basically depends upon the motion of particles. The more the motion the particles have, the more the kinetic energy they will exert. So right?
Yeah.
Okay. So here kinetic theory of gases. So definitely we will deal with the molecules and whose molecules? The gases molecules because we know gas also consists of small atoms or molecules. So the motion of the gas molecules is known as kinetic theory of gases. It explains the behavior in terms of motion of particles. What are the assumptions? We already know gas consists of tiny particles which are in random motion. For there will be no force of attraction or repulsion between the particles. Okay, but they will only collide with each other and the collision are always perfectly elastic. Those molecules would never attract each other as well as never repels each other. But what would happen here is that they will exert force to other and the collision is perfectly elastic, not inelastic. Understood?
Mm,
Also, the temperature is proportional to the average kinetic energy. We already know that if molecules are vibrating, their motion is more. So definitely, if the motion is more, it means it has more kinetic energy. And if a body has more kinetic energy, it means that body has high temperature. Because we know that increasing kinetic energy also increases the temperature. Kinetic energy is directly proportional to the temperature, right?
yeah.
Okay, so can you tell me from this figure whose temperature would be greater? This jar or this jar?
The jar on the right,
The first one or the second one?
second one,
Yes, can you tell me why the temperature is high in the second jar?
because there's more kinetic energy.
Yes, more kinetic energy. Perfectly. Okay, so any question?
Nah.
Okay, now move on towards an important law which is known as the Boyle's law. Have you ever learned about this law, Boyle's law?
I've heard about.
Okay,
I reckon.
okay. So you don't know about this?
though, but I recognize it.
Okay. So Boyle's law is basically it shows the relationship between pressure and volume of a gas. Because we are concerning with the gas, Boyle's law tells us the relationship between pressure and volume of a gas. What Boyle's law describes that how pressure and volume of a gas are related when temperature is constant. Keep understood that in Boyle's law you must have to take temperature constant and you take the relationship between pressure and volume. What is the statement of Boyle's law? Boyle's law tells us that at constant temperature the pressure of a gas is inversely proportional to the volume. What does it mean? It means you must have to remain temperature constant, but the thing is that when you increase the pressure the volume decreases, and when you decrease the pressure the volume increases because there is an inverse relationship between pressure and volume according to Boyle's law. Okay,
Yeah.
so pressure has a direct relation with volume or inverse?
Inverse,
Inverse. What does inverse proportionality means? If you increase something the other should.
decrease,
Yes, and if something is decreasing, the other should,
increase.
yes, increases. So according to Boyle's law, pressure and volume is inversely proportional to each other. It means that if you increase the pressure, volume decreases and vice versa. Okay,
Mm,
so here is the
yeah.
formula for the case of Boyle's law, which is equals to P1 V1 equals to P2 V2. P1 is basically the initial pressure and P1 is basically the initial volume. Let's suppose this is your container. This is your two container, one container and the other container. This container has a volume of gas which is V1 and the pressure on this container is P1. And as you can see to the second container, here you can see the volume of this container is denoted by V2 and the pressure on this second container is P2. So can you tell me in this container, the volume is more or less as compared to second container?
Less.
Whose volume is greater? This container or this container? First one or the second one? Whose
The
volume
the
is?
container on the container on the right.
Oh,
Left.
yes. You mean by the first container has a larger volume, right?
Yeah. Yeah.
Yes. And the second container has small volume?
Yeah.
Oh, yes, definitely. So here you can see when we apply pressure to the second container, the volume decreases. The initial volume is greater, but the pressure is
Mm,
low because we know that pressure and volume are inversely proportional to each other. But in second container, when you apply pressure, you can see pushing down decreases the volume and increases the pressure. When you apply the pressure onto the second container, now the volume decreases. According to Boyle's law, when you apply pressure, the volume always decreases. So this could happen. All right.
yeah.
Okay. So keep remember this formula. We will use this formula in resolving some problems related to Boyle's law. P1 V1 equals to P2 V2. So are you ready for an example?
Mm, yeah.
Okay. So a gas at 1.5 atm occupies 4L. 4L means 4 liters. What volume will it occupy at 2 atm? Okay. Can you tell me atm is what's unit? Either it's pressure unit or something else.
Uh,
ATM. ATM is whose unit? Either it's unit for pressure or something else.
pressure.
Yes, it's the unit for pressure. So what you have to find the final volume. Initial volume is given, which is 4 liters, and you have to find final volume. It means V1 should be 4L, and you have to find V2. Initial pressure is given, which is 1.5 atm, and you have to find, and also the final pressure is also given, which is 2 atm. So P1 is 1.5 atm and P2 is 2 atm. So can you find V2 easily?
Yeah,
Yes, because you know that P1 V1 equals to P2 V2. When you have to find V2, what you have to do, you have to divide this P2 to the other side. So the expression for V2 becomes P1 V1 divided by P2, right?
yeah,
So here you can see P1 V1 divided by P2. Now what you have to do is to just put the values for P1 V1 and P2. P1 is 1.5 and V1 is 4 and P2 is 2. So just calculate and substitute, you will get your answer, which is 3. Because initial volume V1 is given in liters, so definitely your final volume is also in
liters.
liters. Because volume is made in liters. Okay?
Yeah.
Or meter cube as well. Sometimes volume is made in meter cubes and sometimes liters. So now move on towards the graphical representation of Boyle's law, which is important. So here you can see, because Boyle's law tells us about the relationship between pressure and volume, so we have to plot the graph between pressure and volume. The volume should always be taken on x-axis and pressure would always be taken on y-axis. As we know that x-axis is an independent quantity and y-axis is the dependent quantity. Do you know this thing?
Yeah.
Okay. On x-axis, we have to take the independent quantity because volume is an independent quantity, and the pressure, which is dependent on y, on v, that's why we have to take pressure on the y-axis. When we plot the graph between P and V, we will got this type of curve, which is a parabolic curve. Okay.
Mm-hmm.
Why this
Yeah.
curve would happen? Because we know that there is an inverse relationship between volume and pressure. Here you can see as we increase the pressure is low. Here you can see the less value of pressure. But
Yeah.
as you increase the pressure, you can say there is a less value for volume. This is according to Boyle's law. Pressure and volume is an inverse relation. That's why we will got this parabolic type of curve when we plot PV graph. This graph is also known as PV graphs. Okay.
Yeah.
Okay. Now let's plot a graph between P and 1 by V. P and now 1 by V. P has an inverse relation with V, but P has a direct relation with 1 by V. Am I right?
Yeah.
So when we plot the graph between P and 1 by V, we will get a straight line because P is directly proportional to 1 by V, but P is inversely proportional to V. Okay, this is separate. P is inversely proportional to V, but P is directly proportional to 1 by V. So when we plot directly proportional graph, we always obtain a straight line. Okay. So this graph
Yeah.
comes in sometimes in paper. So draw a graph between P and 1 by V. So you will have to plot this. And when they say plot graph between P and V, so this parabolic type of curve should rise. And question?
No.
Okay. So let's move on towards second law, which is known as Charles' law. Charles' law is another gas law. It basically explains the relationship between volume and temperature. As you know that Boyle's law explains the relationship between pressure and volume, but here in Charles' law, it describes the relationship between volume and temperature. In Boyle's law, you know that what we have to remain constant. Temperature, right?
Right. Yeah.
You can see temperature would remain constant in Boyle's law. But in case of Charles' law, what you have to do, you have to take now pressure constant. Okay. Now pressure
Mm.
would remain constant And Charles' law tells us that the relationship between volume and temperature. The statement is at constant pressure, the volume of a gas is directly proportional to the temperature. And you have to take temperature must in kelvins, not in Celsius or Fahrenheit. Because you know that there are three units of temperature Kelvin, Fahrenheit, and Celsius. But the SI unit of temperature is kelvins. So before calculating the problems, you must have to convert your temperature into kelvins. So the statement for Charles' law is that at constant pressure, the volume of a gas is directly proportional to the temperature. What does it mean? It means if you increase the volume, the temperature increases. And if you decrease the volume, the temperature,
Decreases.
gas decreases. So this means temperature increases when volume increases because there is a direct relation of temperature and volume. So here you can see the illustration from this figure. So can you tell me either this volume is greater or this? The first volume or the second volume is greater? V1 is greater or V2?
V1.
Whose
Oh no,
volume is?
V2.
Yes,
V2.
V2. Yes, V2. So V1 volume is less. Yes.
Mm-hmm.
Okay. So below you can see a flame, a Bunsen burner flame. So what you have to do with the flame, we have to increase the temperature definitely. When you put below a flame to a container, the heat from the flame comes to the bottom of the container and the particles gain the heat. And when you know that when the particles gain heat, the kinetic energy of the particles increases. And when the kinetic energy of the particle increases, we already studied that the volume increases. As you can see, these particles gain heat energy from this heat flame, and by getting this heat, the kinetic energy of the particles increases. And when the kinetic energy of the particles increases, automatically the
Mm-hmm.
volume also increases. So that's why you can see the volume for the second case is more as compared to the this volume. All right,
Yeah.
because you will see that in first figure the flame is something low, but in the second figure you can see the flame is higher. A high flame means more heat. You are providing more heat. And if you are providing more heat, it means the kinetic energy increases more. And if the kinetic energy increases more, so definitely the volume increases. Because according to Charles' law tells us that if you increase the temperature of a body, the volume should also increase because there is a direct relationship between temperature and volume. Okay?
Yeah.
Any question regarding Charles' law?
Mm. Bah.
Okay. So what's the formula for Charles' law now? V and T is a direct relation, and the formula becomes for Charles' law is this, which is V1 divided by T1 equals to V2 divided by T2. V1 is the initial volume and T1 is the initial temperature. V2 is the final volume and T2 is the final temperature. All right.
Yeah.
So keep remember this formula. We will also use this formula in solving practical problems. Now move on towards the graphical representation for Charles' law. Here you can see, in the case of Boyle's law, we plot graph between PV, which is known as PV graph. In the case of Charles' law, because Charles' law tells us about the relationship between volume and temperature, so we have to take temperature on x-axis, which is an independent quantity, and volume we have to take on y-axis, which is dependent quantity. And we know that whenever we plot a graph between directly proportional some contents, so what we get, we got a straight line because volume is directly proportional to the temperature. That's why we obtain a straight line. Okay.
Yeah.
Okay. So as you can see here, as you increase the temperature, the volume also increases. When you increase more temperature, the value for volume is also increases. The more the temperature you will increase, the more the volume will increase. So that's why you will obtain a straight line. So this is the graphical representation for Joul's law. Any question?
Yeah. Nah.
Okay. Now move on towards examples, working examples. So let's start. A gas has volume 500 centimeter cube at 27 degrees Celsius. So the volume is given, and definitely this is the initial volume. So the value is 500. So this is V1, right? V1 is 500,
Yeah.
and this is definitely an initial temperature. So T1 is 27 degrees Celsius.
Yeah.
Find its volume at 127 degrees Celsius. Now you have to find the final volume when you increase this temperature. So it means you have to find the value for V2. T2 is given, which is 127 degrees Celsius. Before solving this problem, can you tell me the temperature unit is perfect or not perfect?
Um, Perfect.
I think not perfect because in the statement of Joul's law, it says you have to take temperature in kelvins,
Oh, right.
right? So
Yeah.
we have to convert this Celsius into kelvins. We know the conversion. We know how to convert Celsius into kelvins. There is a formula to convert Celsius into kelvins, and the formula is there, which is you just have to add the value of your degree Celsius with 273. So the value in degrees Celsius is 27. What you have to do, you just have to add 27 with 273. You will get your answer in kelvins and you will get 300. Now your initial temperature, you not take 27 degrees Celsius. Instead, you have to take 300 kelvins. Okay.
Mm-hmm.
So this is the value of T1. Same thing you have to do with the T2, which is 127 degrees Celsius. What you have to do, you have to add 273. So 172 plus 273, you will get 400. So the value of T2 is now 400 kelvins. So T1, T2 is given. Also V1 is given. And what we have to do, we have to find V2. So in this problem, we will only see the expressions of volume and temperature. So can you tell me whose law explains the relationship between volume and temperature? Either Boyle's law or Joul's law?
Charles.
Yes, Joul's law. So what formula we have to use? Boyle's law formula or Joul's law?
Charles law.
Joul's law. And what's the formula for Joul's law? Can you tell me?
V1 V2 V1 T1 equals V2 T2.
Yes, V1 divided by T1 equals to V2 divided by T2. And what you have to find, you have to find V2. And what would happen? This T2 goes to the other side. V1 T2 divided by T1. Now what you have to do is simply putting the values for V1, which is 500, the value for T2, which is 400 kelvins, and divided by T1, which is 300. After substituting, you will get your answer, which is 668.66.67 centimeter cube. Because the initial volume is given in centimeter cube, that's why the final volume must be also in centimeter cubes.
Yeah.
Okay, okay. Now move on towards second problem. A balloon has a volume of 2.5 liters. So definitely this is the initial volume. So initial volume, which is V1, is 2.5 liters at 250 kelvins. So do we need any conversion here?
Nah.
Oh, yes, no. Why not? Because already temperature is in kelvins. Okay, so if temperature is already in kelvins, so we don't need to convert. So T1 is 250 kelvins, and the what is the volume at 300 kelvins? It means the T2 is also given, which is 300, and you have to find the final volume. It means you have to find V2. The same formula, the same we have to use the formula for Charles law, which is V1 divided by T1 equals to V2 divided by T2. And if we want to find V2, the expression would becomes this.
Yeah.
Simply putting the values for V1, which is 2.5, T2, which is 300, divided by T1, which is 250, you will get your answer. By substituting using a calculator, you will get which is 3 liters. Because our initial volume is given in liters, that's why our final volume would also be in liters. Any question?
Mm. Uh,
Now let's move to the last problem. A gas has a volume of 350 centimeter cube at 0 degrees Celsius. What will be the volume at 100 degrees Celsius? So again, initial volume is given, which is 350 centimeter cube. So the value of V1 is 350 centimeter cube at 0 degrees Celsius. So we need any conversion here for T1?
yeah.
Yes, we need. So how can we convert Celsius into Kelvins?
Add 273.
Yes, by just simply adding 273. So because Celsius, 0 degree Celsius, so 0 plus 273, you will get the same 273. So the value for T1 is 273 kelvins. And what we have to find? We have to find the final volume. Again, we have to find V2 at 100 degrees Celsius, means the value for T2 is 100 degrees Celsius. And again, we need to convert into kelvins. So what's 100 degrees Celsius into kelvins?
Uh, 373 Kelvin.
Yes. Yes, 100 plus 273, it becomes 373 kelvins. So we have to use T2 equals to 373 kelvins. Same, this formula express about the relationship between volume and temperature. And we know the relationship between volume and temperature we will discuss in Charles law. So we have to use the formula for Charles law, which is V1 divided by T1 equals to V2 divided by T2. And we have to find the final volume, which is V2. So your formula becomes look like this. By simply putting the value for V1, which is 350, and T2, which is 373, and last T1, by calculating, you will get your answer approximately equals to 478.57 centimeter cube. Okay.
Mhm. Yeah.
So any question regarding these problems?
No.
Okay. So here, quick quiz for you. Can you tell me what happens to the pressure when the volume is halved?
But it also it doubles.
Uh, oh, yes, it doubles. What happens to the pressure when the volume is half? It doubles, right. According to whose law? Boyle's law or Charles' law?
Boyle's law.
Yes, Boyle's law. Can you tell me what is the statement for Boyle's law? Boyle's law tells us about the relationship between.
Uh, Pressure and volume.
Yes, pressure and volume. And what is the relationship between pressure and volume? Either direct relation or inverse relation?
Inverse.
Yes, inverse relation. So that's why the if the pressure, what happens to the pressure if the volume is half? That's why if the volume is half, so the pressure automatically increases by 2 times because there is an inverse relationship between pressure and volume. If the volume is increased by 3 times, the pressure would increase by 3 times. If the volume is half by 10 times, the pressure would increase by 10 times according to Boyle's law.
Hmm. Yeah.
Okay, can you tell me what is the SI unit of temperature?
Kelvin.
Yes, kelvins. Perfect. So can you tell me, state the formula for Charles' law?
V1 divided by T1 equals V2 divided by T2.
Yes. And can you also explain me the formula for Boyle's law?
V2 P P2 equals V1 P1 or
Perfect.
P2 V2.
Yes,
Yeah.
perfect. What is the value of absolute zero in Celsius?
Uh, Negative 273.15 degrees.
Yes, 0.15 degrees Celsius. This is the lowest
On
possible value theoretically achieved, and this value is known as absolute zero. Keep remember this value. This value sometimes comes in MCQs, like what is the absolute zero in Celsius? So absolute zero in Celsius is 273.15. Okay,
uh-huh.
and after
Yeah.
point we have to read separately, like 0.15, not 0.15, right? According to
Yeah.
the rules of math, after
Uh-huh.
the decimal, you have to read each number separately. Like 273, you have to combine
Yeah.
really, but
I know.
after point, it 1 5, not 15. Okay,
Yeah.
okay,
Yeah.
good. Which method of heat transfer does not require a medium? We will discuss this in previous
Radiation.
lectures. We discuss about modes of transfer of heat like conduction, convection, radiation. So from those three, can you tell me which method do not require medium to travel?
Radiation.
Yes, radiation. And the second name of radiation is light.
Uh,
Light, simply.
Light.
Yes,
Yeah.
simple light. Light is a radiation. Okay.
Hmm.
Okay, so can you tell me a formula for pressure we discussed in starting lectures?
P equals F over A.
Yes, force per unit area is pressure. So pressure is a direct relationship with force. If you increase the force, the pressure increases. And pressure is an inverse relationship with the area. The more the area, the less the pressure would exert. If the area is small, it will exert more pressure because pressure and area has an inverse relationship with each other. Any question?
Nah.
Okay. So these are your assessment questions. You will do practice at your home. Okay.
Hmm.
Okay. So any question regarding today's lecture?
Nah.
Okay. So can you tell me either this time is suitable for you? Class on Saturday at this 1 p.m. UK time. Any issue?
Uh, uh, Probably not. No.
Not really. In future, if we take classes on Saturday at this time instead of Sunday, any problem on?
Nah, that's fine.
Okay, so if no problem, so from next now onwards, we will take class on Saturday and at the same time, 1 p.m.
Alright.
So you're at home at this time, right? Not at school.
No.
Okay. So next week would be class on the same day and the same time, 1 p.m. on Saturday.
Okay.
Thanks for the lecture.
Uh,
Good luck. Allah Hafiz.
that was bye. Bye.